Good evening, everybody, and welcome into another program with the Schaumburg Library. I'm Chris, your adult programs coordinator at the library, and this is our third installment of Night with the Museum. Now, we broke the rules a little bit here. Traditionally, it's a museum from not inside the state of Illinois, but I don't mind bending the rules for who I know is a library patron favorite, Michelle Nichols up there, or wherever she happens to be on your screen, from the Adler. And what timely time to have her because we have an eclipse coming up. And quick reminder, Michelle and I talked about this before. If you haven't registered to get a pair of eclipse glasses from the library, you're gonna want to do that. We're not just handing them out at the watch party. You're gonna need to register for those. The event date to register for picking up your glasses is April 4th. That's just the place to go and register. I put it in the chat so you can easily access that. We will email you when you can pick up your glasses. I believe, don't quote me on this, but I believe we will start handing them out on April 1st. But you will get an email. So if you haven't registered to get those yet, make sure you get on over to our website and you register to get your glasses. Now, without further ado, I want to make sure that we get this wrote on the show. Oh, it's really important also that I point out we are trying to beat out Wheaton Library, who holds Michelle's record for the most attendees. And I know you guys are not going to let me down. We are going to beat out their number. I want to say it was in like the 150s. Um, so or no, it was in the 170s. So we got to beat them out, guys. I believe in us. I know we can. I know you guys won't let me down. I am super competitive. So let me really quickly, I don't want to take up any more of her time than I already have, introduce a woman who needs no introduction, but I'm going to do it anyway. Michelle Nichols is the Director of Public Observing at the Adler Planetarium in Chicago, Illinois, and has worked at the Adler since June 1995. She holds a Bachelor's of Science in Physics and Astronomy from the University of Illinois at Urbana-Champaign and a Master's of Education in Curriculum and Instruction from National Louis University. Ms. Nichols leads all of the Adler Planetarium's telescope, observatory, and public sky observing initiatives and events. Oh, and I totally forgot because I went off on my own tangent. If you have questions for Michelle at any point during the program, don't forget to throw those in the Q&A. We will take all questions at the end of today's presentation, but make sure you're putting them in as we go so you don't forget them at the end. And if you're experiencing technical difficulties, the Q&A is the best place to get a hold of me. I'll be keeping my eye on that during the presentation. And if you have technical difficulties, I am more than happy to go back and forth with you in the Q&A to try and sort out your problem. And we've also enabled closed captions for your convenience. Now I will stop taking up Michelle's time, and I'm going to pass the night over to Michelle. Michelle, take it away.
Thank you so much. And yes, the total from Wheaton from last week was 178. So I have faith in you, Schomburg. You never let me down. So, and actually, it was 101 online. So if you get to 102, I consider that a win. All right.
I'm really
But
going to quickly interrupt you, Michelle, because
yep.
we have already broken 102 online because of the people who have multiple people watching with them at home. So we've already beaten that number.
Yay. That's great. So keep going. So everybody, we've got a solar eclipse coming up. I remember coming to the library in 2017 to get everybody all set for that one. And 2024, it didn't seem like forever away, but it seemed like a ways away. It is now less than 3 weeks away, Monday, April 8th, 2024. Somebody asked me today at work, are you ready? And I'm like, nope. So, but I will get all of you ready, and then I will just freak out on my end about all the stuff that I have to do between now and then. But anyway, we're going to talk a bit tonight about why solar eclipses are relatively rare. I know that word tends to get thrown around a lot in news stories and things, but they kind of are rare. And then we will talk about what to expect on April 8th for those staying in the Chicago area and for those planning to travel to potentially go see totality someplace else. Then we will talk about a couple of resources that will help you plan depending on wherever you are. And finally, I would love your questions. So definitely pose those, even if I answer it later. You don't have to wait to to ask the question. So I might answer it at some point during the program, but I don't want you to forget what your question was. So definitely just throw that in there and we will sort all that out at the end. So let's get started. And my screen is already being shared. So let's dive in. Okay, so I'm going to start this animation in just a second. If you're having trouble seeing it, that's kind of the point. This is actually to scale. This is showing you a top-down view of the Earth-Moon system. That little tiny circle in the middle is the Earth, and that even smaller circle out to the edge is the Moon. And this is to size and distance scale if you shrink the whole thing down. It is often not portrayed to scale. We often see imagery or drawings of the Earth Moon system where the moon is wildly too large and everything is all squished together. But this is actually to scale. The sun is over off the edge of the left side of your screen. And so the sun shines on everything and the sun shines on the earth and the earth has a shadow cast into space. The sun shines on the moon and the moon has its shadow cast into space. Now, when solar eclipses occur, they occur when the moon gets in between the earth and the sun. And the moon blocks out our view of the sun, either partly or fully. Well, the moon goes around the Earth every 29 and a half days on average. It's not exactly that number, but close enough. And so you would expect as the moon comes around, gets in between, we should have a solar eclipse every 29 and a half-ish days. But that does not happen. Well, this is the phase of the moon called new moon. So I'm going to start this animation and we're going to go through a couple new moons here and see what happens and see why solar eclipses don't actually happen all that often. So we've got the moon going around the Earth. This is greatly sped up, of course. So the moon is in between, and let's look at this from the side. And when you take a look at this from the side, you can see one very important point that isn't often portrayed in the drawings, and that is the moon's orbit is tilted with respect to the Earth. So when the moon's shadow is cast into space, it usually misses the Earth. It will pass either above it or below it. And in this case, it's shown below. So every new moon, or almost every new moon, the shadow misses, you don't get a solar eclipse. But if we take a look at what the moon's orbit does, it wobbles, kind of like a top that's kind of spinning itself down. And then occasionally, about twice a year on average, the moon's orbit does line up so that the moon's shadow falls across the Earth. And if you are underneath that shadow at just the right time, you get to see a solar eclipse. So on average, they occur about twice a year. But if you're thinking to yourself, I don't remember seeing two of them a year, that's because you might not see one of them. You might not see either of them. It may be several years in between you seeing one solar eclipse to the next one that can be seen over your location. There's some other reasons why these don't happen all that often. Let's take a look at the next animation. And this is an animation that was created for the 2017 solar eclipse, but it definitely can illustrate several things. First off, before I even start it, take a look at the shadow cast by the moon. Notice there's a darker inner part and a lighter outer part. So the moon is an extended object. The sun is an extended object. The sun being an extended light source creates two regions of shadow, darker inner and lighter outer. So let me start this animation and we'll take a look at that in a little bit more detail. We're going to change the orientation. And as you can see, we've got the shadow of the moon falling across the Earth right here. And it is moving. The moon goes around the Earth. The shadow moves. And so if you take a look, I'm going to stop it right here. Notice we've got that darker inner shadow and the lighter outer shadow delineated by this yellow circle right here. So the darker inner shadow is where you get to see a total solar eclipse. So it starts off as a partial eclipse, gets more and more coverage. And then for a brief period of time, that dark inner shadow passes over you. And so we've got that dark inner shadow here, again, greatly sped up, but it is traveling quite fast. It is traveling well over 1,000 miles an hour across the surface of the Earth. But the time it takes for that dark inner shadow to pass over you, that is totality. That is the time of totality itself. In 2017, for that eclipse, the totality was a little over 2 minutes in length at most. And if you are then within this lighter outer shadow, you get to see a partial solar eclipse, only a partial solar eclipse. You don't get to see totality. But the closer you are, if your location is closer to where the dark inner shadow is, the more of the sun is covered by the moon. And the farther you are to the edge, the less of the sun is covered by the moon. If you are outside that light outer shadow, no solar eclipse for you either at all, or in this particular case, maybe you're over here to the east, it just hasn't gotten to you yet. Um, but a few things. First off, we delineate the region where the dark inner shadow passes over as a path. So this is that orange or reddish colored path that's traced out on the surface right here. That is the path of totality. But the moon's shadow is an oval shape or a circle shape. So it at any one time it's that circle shape, but tracing out the region it passes over, that is the path of totality. So again, the shadow then encounters the earth, passes over, and then falls off the other side. So that is your entire solar eclipse. And again, this is to scale. So notice by the time that dark inner shadow gets to the surface of the earth, the dark inner shadow is pretty small. For 2017, it was only 78 miles wide. For 2024, it's actually going to be, I'll restart this so you can have something to look at. For 2024, the dark inner shadow is a little bit bigger. It's about 115, 120 miles wide, something like that. Why the difference? The moon's orbit around the Earth is not a perfect circle. So therefore, sometimes the moon's a little closer in its orbit, sometimes it's farther away. In 2017, at the time of the solar eclipse, the moon was about 231,000 miles from the Earth. In 2024, on April 8th, at the time of the eclipse, the moon will be 223,000 miles from the Earth. Little bit, uh, uh, little bit closer to the Earth means a little bit wider shadow. So therefore, the amount of time it takes that wider region to pass over you results in a slightly longer period of totality, which in this case will be a little over 4 minutes in length at its greatest extent. So it's not a lot of time, but it's definitely more than we got in 2017. So I do want to show you the animation for the 2024 eclipse. So this one is depicting what is going to happen on April 8th. And what's going to happen is the moon's shadow will encounter the edge of the Earth and it will come across the face of the Earth. Again, this is greatly sped up. That red circle is showing you where totality will occur, and those other colors are showing you where the partial solar eclipse will occur. So as the dark inner shadow region passes over, it'll come up through Mexico and up through Texas and Arkansas, Missouri, Illinois, Indiana, Ohio, and out toward the Northeast, New York, a little bit of Canada, and then toward the Northeast US, and then it goes off the other side of our continent. So the regions that get to see totality this time, it includes a lot more larger cities. So that we were actually kind of grateful for, because in 2017, one of the main problems we were dealing with was not a lot of hotel rooms in the places that we're going to experience totality. That was a problem, but there are much larger cities included. I can almost guarantee there's a few of you who might be going to Indianapolis or maybe Carbondale. If you're going to Carbondale, I will see you there. Maybe going to someplace in Texas. And I've been talking to people who are a bunch of folks going to Indiana, several folks going to Arkansas and Missouri. So we definitely can spread out a bit in this country with hotel rooms to stay at, which is not an insignificant problem when you're trying to accommodate lots and lots and lots of people who want to see a phenomenon that is essentially happening in our backyard. Just one thing to remember is, actually, I'm going to start this over just take a look at the fact that the shadow doesn't cover the whole Earth. So it's not like everybody on our side of the planet is going to see the eclipse. Check out our friends in South America. Even though it will be daylight at the same time that the eclipse is occurring for North America and South America, we're not all going to get to see the eclipse. Um, it's mostly going to be Central America, North America, not all of Alaska, just a little bit of it, and a few other regions to either side. Hawaii will see a partial eclipse. The Caribbean will see the partial eclipse, but only a tiny little bit of South America will see the partial eclipse. So that also contributes to why this is a rare phenomenon. And then finally, why this is rare. If you looked at that dark inner shadow region, it's pretty small. You have to be in a very confined location to see totality or have a chance at seeing totality. So the average amount of time it takes for the same spot on Earth to see one totality to the next, on average, it's every 375 years. It's not like clockwork. For example, our friends down in Southern Illinois, they get about almost a little under 7 years in between totalities. Chicago, the last time Chicago saw totality was 1806. The city of Chicago did not exist in 1806. The next time Chicago proper will see totality is 2099. So this gives you a sense that this really doesn't happen all that often. The reason that we've got totality occurring in such a short period of time in Southern Illinois is because eclipse paths can cross. That part is also not extraordinarily rare. Um, but where those eclipse paths cross doesn't always happen over land. Our planet is covered in water. So that makes it a rarer event. Maybe it doesn't occur over a populated location. That makes it a rarer event. So it is pretty special for that to be occurring primarily in our state of Illinois, which is pretty awesome. Okay. Now that I've shown you the two scale versions, the out of scale imagery starts to look a little comical. Anyway, the reason I want to point this out is for another reason, and that's coming up this weekend. We have something associated with the solar eclipse that is usually associated with a solar eclipse, but not always visible to the places that get to see the solar eclipse, and that is a lunar eclipse. So if you've got the orientation right for the solar eclipse at new moon, you've got the orientation right for the moon's orbit with the Earth for the lunar eclipse to occur at full moon. So let's talk about the lunar eclipse. Don't get excited. I'm talking about it only because I'm expecting there might be some clickbaity news articles that might appear about it. I'll explain why as we go along. Not all lunar eclipses are made the same. I mean, the phenomenon is the same. How they all turn out is not exactly the same. So let's explore that. So this is also wildly not to scale, but we've got the moon's orbit around the Earth. And I'm going to start with this. I'm going to show us a few terms. First off, the dark inner shadow of the Earth and the moon is called the umbra. This comes from the same root word that gives us the word umbrella. It means to block or to shade. So the dark inner shadow is called the umbra. If the moon's orbit goes through the umbra completely, you get to see a total lunar eclipse. That's where the moon turns that red or gray or orange color. We saw a couple of those, one in 2021 and one in 2022. They were really nice lunar eclipses. Sometimes the moon's orbit doesn't take it all the way into the dark inner shadow and just it kind of clips it, or maybe clips it a little bit. It might clip it a bit more. We call that a partial lunar eclipse. All right. So it looks, part of the moon will look lighter and part of the moon will look a lot darker. Then we've got some lunar eclipses where the moon's orbit only takes it through the lighter outer shadow, not into the darker inner one. And we call that a penumbral lunar eclipse. This is the one that's going to occur on the evening of March 24th into the morning of March 25th. So this is Sunday night into early Monday morning. the next couple slides are going to explain why you don't have to get terribly excited about this particular lunar eclipse. By the way, we will get one of these total lunar eclipses March 2025. I think it's March 13th, but don't totally quote me on that. I haven't memorized the date yet. We will get one of these partial lunar eclipses on September 17th of this year. And it's in the early evening. We don't have to stay up till 2 in the morning to see it, which is great. But the penumbral lunar eclipse is going to be Sunday night into Monday morning. So it'll start at 11:53 p.m. Central Daylight Time. It will end at 4:32 a.m. Central Daylight Time, and at its maximum, the moon will be within the penumbra shadow, that lighter outer shadow, to this extent right here. Notice, not even the entire extent of the moon will be fully within that lighter outer shadow. This outer circle delineates the lighter outer shadow. The smaller one at the bottom, that delineates the darker inner shadow. Note that none of the moon is going to reach that darker inner shadow. So it's going to come in, skim the lighter outer shadow, and then go back out over the course of about 4 hours or so. So what will this look like? You may be having a tough time noticing a heck of a lot of difference between the no eclipse and this eclipse. Now, this particular image, the where the shading is located is going to be a little different for this eclipse, but I want you to notice the effect. This is not a dramatic shading change. People who don't know the lunar eclipse is occurring probably won't even figure out there's a lunar eclipse happening. They might think, oh, there's a little bit of a cloud up there in the sky. What will the astronomer in the group of us here be doing amongst all of us here? I'll be sleeping. So if you don't want to stay up, it's okay. The point is, the reason I'm kind of harping about this a little bit is I fully expect someone to write a clickbaity article about this and say, lunar eclipse, these are rare. They only occur a few times a year. And they'll show some stock photo of a dramatic red colored lunar eclipse. This is not one of those lunar eclipses. It is a very minor shaded moon for this lunar eclipse. So now you know, if you want to stay up, great. The peak of the eclipse is at 2:12 a.m. So there you go. If you happen to be up, and if it happens to be clear out, just look out the window, check out the moon, see if you notice a difference. If you do, great. But do not expect that dramatic shading change. Okay. And I find it interesting. I only have to talk about this lunar eclipse for 2 more presentations, one tomorrow night and one for Thursday night, and then we can forget this lunar eclipse until the next one in September, which will be a little bit more interesting to look at, in my opinion. Okay. Solar eclipse. That's why we're all here. So the solar eclipse is occurring on Monday, April 8th, 2024. And at its greatest extent across the state of Illinois, the moon will cover the sun in northern Illinois about 92-ish%, on down more and more. And as you get closer and closer to southern Illinois, at its greatest extent, more and more of the sun is covered by the moon. Till the path delineated by these dotted lines, you get totality. That's where you get the moon covering the sun at 100%. The entire state will see a partial solar eclipse, but only folks in that dotted line path there will see a total solar eclipse. The folks closest to the center of the path will see a longer period of totality. The folks closest to the edges of the path will see a shorter period of totality. But even people located about 2/3 of the way out from the center, they're still going to get a couple of minutes worth of totality. It's when you get to the very edges, when you only have a little bit of that moon shadow passing over your location, then that's when you get the totality occurring for tens of seconds. So if you know anyone, by the way, who lives at about 99%, please encourage them to drive those last few miles to go into the path of totality. 99% coverage of the sun is not 100%. There is a dramatic difference between the two. I am going to show you what to expect if you're going to stay up here in Northern Illinois versus those going to totality. And you're gonna see the effects that I can talk about for totality. There's a lot more that you can have the opportunity to see if it's going to be clear out. Fingers crossed for all of us. All right. For those who are staying in the Chicago area, at approximately 12:51 p.m., and I'm saying approximately, these times I did for the Adler's location, close enough for all of us in the Chicago area, within a few seconds or tens of seconds. So late 12:50, early 12:51, close enough. You're going to start to see the moon peeking over the edge of the sun. And it may take a few seconds or so before you really actually start to see it. Then the moon will continue to slide slowly across the face of the sun, so that a little over an hour later, we get to see approximately 94% coverage. By comparison, 2017 was about 86 or 87%, depending on your exact location. So this is what it will look like at the peak of the eclipse, which is at 2:07 p.m. Central Daylight Time. The moon will continue to slide and it will keep going, and then the eclipse will be over at 3:22. So the one good thing about a partial solar eclipse that totality people don't exactly have the luxury of is you have time. We have time. We have about 2.5 hours to have a chance at seeing some portion of this eclipse. There's no one particular moment that you need to be looking up at the sky. Those who are going to totality, you have the partial eclipse. You have over an hour either side of totality, but you're sweating bullets in terms of whether it's going to be clear out or not during those few minutes of totality. So that's what people get really anxious about. Sometimes Earth gets in the way, you never know. But here is something that all of us can look for during the eclipse if it's clear out. And that is when the sun is covered by at least 50%. I want you to start looking around at your shadows all around. Trees, houses, buildings, cars, whatever. Look at the shadows. And as the sun is covered more and more and more, the edges of our shadows are going to get sharper and sharper. When you have the sun just as a little sliver in the sky, the edges are very sharp. You probably don't even notice how fuzzy edged all of our shadows are. The sun is an extended light source, so that creates fuzzy edged shadows all over the place. And so definitely look down at your shadow as much as you might be looking up safely at the sun itself. So that is a phenomenon we can all check for. So hopefully it is clear out during the time when the sun is mostly covered, so you can check for this. All right, for those going to totality, here are the things you can look for. All right, first off, this is going to be a video. I'll start it in just a second, but this is a screen. This is a video of a screen that, and by screen, I mean it was probably a tarp or something that was clipped up. You can see the clip right here. There's some pegboard over here. It looks like someone was using that maybe for a pinhole projector. I'll get to that in a little while. But the camera was pointed at this screen right here. And the video starts at about a minute prior to totality for this particular location. Now, this is at real time. This is not a sped up video. Occasionally, you're going to see a bug or two fly across the view. But what you're going to be looking for as we get closer to totality is you're going to start to see the screen seem to shimmer a little bit. And I'm seeing it on my end. I'm not sure if you're going to see it on your end just yet, but I'm seeing it on my end. So just wait a little longer. And that shimmery effect is called shadow bands. We did see this after the solar eclipse in 2017. I was kind of surprised that I wasn't expecting to see them. But this is an effect that happens about a minute prior to totality up to right up close to the time of totality. And now you can see more and more. That's a bug going across the screen right there. But now you can see that shimmery effect. Now the video is going to get darker and darker because this is getting just prior to totality for these folks right here. And now you can really see it. Now what's happening is that sliver of sunlight is shining through different temperatures, different densities of air in between you and up above your head, essentially. And so that creates ripples of light on the ground. They're really hard to film. They may or may not be visible. They may or may not be visible to your eyes, but it is definitely something you can look for. And that is definitely something that if you're going to go to totality, just get a white sheet and put it down on the ground, anchor the corners, and just keep an eye on it. So about a minute prior to totality, check the sheet and see if you can start to see these ripples. If you don't see them, not a big deal, but you can look for them about a minute prior to totality and up to about a minute after totality. So that is something our totality friends can look for. All right, next. A few seconds prior to totality, about 3 or 4 seconds prior, you got those last little bits of sunlight shining through little valleys on the very, very edge of the moon. And those little dots of sunlight shining through those little valleys, the whole rest of the bright part of the sun is covered except for just some little vestiges of light. That's called Bailey's beads. And so again, you can look for this about 3 or 4 seconds prior to totality, which means it helps to know exactly when totality will occur for where you're going to be. I will show you where you can get that information if you don't already have it. You give me just a second. I'm going to take a drink of water. All right, next, totality. This is what you're gonna hopefully see. You're going to see the shadowed side of the moon, which is the side facing us. You're going to see streamers, what looks like streamers of light, white light, dim white light around the rest of the sun. That is the corona. That is the sun's outer atmosphere. It is only visible during a total solar eclipse. It's always there. It's just that the bright part of the sun overpowers it. And so we have to block out all of the bright part of the rest of the sun in order to see it. Now, I know that there's a lot of misconception out there about seeing eclipses. If you are looking at the bright part of the sun, the rule is any part of the bright sun part of the sun visible, you got to use solar glasses or solar viewer. All right. So any of that, you need eye protection to be able to see that. During totality itself, you absolutely need to look at this with just your eyes. You cannot use solar glasses or a solar viewer during totality. Why? It's not bright enough to be seen through your solar glasses. But people think, oh, I need to wear solar glasses because eclipses are dangerous. No, the bright part of the sun is the dangerous part. You don't look at the bright part of the sun during any other day of the year. Don't look at it directly with just your eyes during a total solar eclipse or during a partial solar eclipse. Or during the partial phases prior to or after totality. But totality itself, you must look at it with just your eyes. It's only about as bright as the full moon in the sky, and that's not bright enough to have the light be seen through your solar glasses. But this region of the sun is safe to look at. I also occasionally get questions about what the pink stuff is. These are prominences. And these are loops of gas that can sometimes be seen on the edge of the sun. They may or may not be visible during totality. It's something you can look for. If you see them, great. If not, no big deal. It just depends on what the sun's activity level is at that point. So maybe we'll see some. So fingers crossed that we do. Also, the shape of the corona might be different from what you see in this picture. It also depends on what the sun's magnetic fields are doing. Sometimes the corona is more circle shaped. Sometimes it's more oblong shaped. Sometimes you see more streamers. So again, won't know till we actually see it, which is kind of the fun part. We can predict solar eclipses in advance, but we can't predict exactly what the sun is going to look like when the totality actually occurs. The sky above you is dark. All right. Not pitch black. I want to temper expectations. It's not a pitch black sky. You can see to walk around. It's kind of the brightness sort of in between after sunset and a full moon night, somewhere in that range. Also, the horizon will probably be lighter in color than the sky above you. You're looking out toward the edges of the moon's shadow at that point. So it's important to look around the sky also because you might see some objects in the sky. In this picture right here, you might see the dot over to the right hand side. I'm going to guess that was Venus because Venus is sometimes visible or often visible during total solar eclipses. So what will be visible in the sky? We will have up to 5 planets visible in the sky during this particular solar eclipse. So this is only for totality, remember. And we will have Jupiter up to the upper right, Mercury, that might be tough to see, but I'm going to give you a tip on how to actually see it, or to try to anyway. Venus to the lower right, and then Saturn and Mars to the lower right of Venus. You'll also see a label here for a comet, Comet Pons Brooks, also called Comet 12P. Don't get too excited about that comet. It's not going to be terribly bright. I don't expect it to be visible during totality. I also don't want you to take precious time away from the minutes or seconds of totality that you have to look for something like a comet that you actually will be able to see briefly after sunset that same night. So don't waste your time looking for a comet. You probably would need binoculars in order to see it, which, sure, if it's during totality, the moon 100% covers the bright part of the sun, you could use. However, please consider not doing that. Number one, you want to look at totality. The planets, you can see them at night, either in the morning before sunrise or at night after sunset. So you've seen the planets, so don't worry about that. Also, you don't want to accidentally lose track of time and the bright part of the sun starts reappearing and you're checking out planets in the sky and you don't have solar filters on the front of your binoculars. You don't want that to happen. So I'm here to encourage you, just enjoy the planets with your eyes. Don't worry about taking a telescope. Don't worry about taking binoculars. They're not going to help you enjoy the eclipse any better. They're just be to be something you're just going to fumble with and waste time by and not check out totality itself. Now, one caveat. I mentioned that Mercury might be tough to see. Saturn and Mars might be a little tough to see. Um, Totality is going to occur. At most, it's a little over 4 minutes in length, depending on where you're going to be, which means your eyes are not going to fully adjust to the dark. So you might miss some detail in the corona. You might not be able to see Mars. You might not be able to see Mercury. We'll see. But I am going to give you a tip that you can consider doing that will help you during those few minutes of totality to potentially see more detail in the corona and see maybe all 5 of those planets in the sky. And that is wear an eye patch. Now, there are diehard eclipse chasers that do this. If you're going to go to a place where you've got eclipse chasers, people who go to every eclipse that they possibly can, you might see them wearing an eye patch. Why are they wearing an eye patch? Why do they want to look like a pirate during a total solar eclipse? The reason is they want to look like a pirate because the pirates knew what they were doing when they were wearing their eye patches. Have you ever thought why a pirate wears an eye patch? It's not because they were all bad in battle. They did not all lose an eyeball. Right now, I know several of you are giggling because that's what you probably thought, because no one ever told you why a pirate wears an eye patch. Just somehow we all think, oh, pirates lost an eye. No. So sea battles would occur during the day. You're probably not going to fight another ship at night. Can't see it. It's dark out. Um, so these sea battles would happen during the day. Pirate swings over to the other ship. He's got his eye patch on. He's been wearing it for maybe 20, 30 minutes at least. He swings over to that other ship. He's battling the guys there on the ship, and he knows, oh, I got to go down below deck. So I got to go down below deck, and it's dark out there, or it's dark down there. So I'm going to go down below deck, and I'm going to say, oh wait, everybody, we need to wait and hold off on fighting for 20 to 30 minutes till my eyes get adjusted to the dark. No, he's got that eye patch on. He's going to switch the eye patch from the eye that's been adjusting to the dark under the eye patch and switch it over to the other eye so that now this eye can help him see in the darkened environment below deck. And I know everyone is now giggling, like, why didn't anyone tell me this story? Why didn't anyone write it down? Well, all the pirates knew it. They didn't have to write it down. This is common pirate knowledge. So this is common eclipse knowledge too amongst eclipse chasers. So if you want to try this, go right ahead. Yes, you might look like a goofball to other people. However, you are going to see more detail in the corona. You might actually see all 5 of those planets in the sky. And so give it a think in terms of whether you might do that or not. Don't spend a lot on the eye patch. Just go to a costume shop or a party store and get a cheap one. And then bring more. Once you start telling people this story, they might want an eye patch too. There you go. Everybody can look like an eclipse goofball in a group. And if you all do it, well, maybe you'll all enjoy the eclipse even that much better. Okay. Moving on. The totality occurs, the moon is sliding away, and the bright part of the sun starts to become visible. But the first place it becomes visible is right there at a deep valley, right there on the other side, the other edge of the moon. And that part gets brighter and brighter. That's called the diamond ring. And for Bailey's beads and the diamond ring, it pays to know exactly when the eclipse is going to occur. Again, I'll get to that in just a second where you can look it up. The plus or minus in terms of our calculations for solar eclipses is an accuracy of plus or minus 3 or 4 seconds. So any time that you see listed online for wherever you're going, it's plus or minus 3 or 4 seconds. All right. Bailey's beads occurs about 3 or 4 seconds prior to totality. The diamond ring occurs after totality, but I don't want you looking at either one of them with your unprotected eyeballs for more than 2 seconds. Count to yourself, 1, 1,000, 2. If you're still seeing the bright part of the sun, put those solar glasses back on. You can glance, you can't stare. That's where people get into trouble with eclipses, all right? Because we don't stare at the sun any other day. We aren't going to stare at the sun during a partial solar eclipse either. I know it's tempting, but just don't do it. There were about 36 or so cases of eye damage in 2017 because people stared at the sun for too long. How many were kids? 0. See, the kids are smarter than we are. All right. They know to listen and not stare at the sun. Don't stare at the sun. Right. I also am not going to tell you a time that you actually like up to a certain time. How long can you look at the sun? Not going to tell you. Don't ask that question because I'm not going to answer it. So just don't. Just enjoy. All right. Use those solar glasses. That's what they're there for. Okay. Now I'm going to show you this website right here, timeanddate.com. Timeanddate.com. All right. Now, holy cow, I'm seeing 90 messages in the chat. Wow, I hope those are all, this is awesome stuff. And hopefully not all. I'm having problems seeing everything Michelle is showing. All right, I'm going to stop sharing my slides and I'm going to start sharing a website. So here we go. All right. Okay, so we've got this particular website here called timeanddate.com. I want you to go to the sun, moon, and space dropdown. I want you to go down April 2024 total solar eclipse, click, and on the page that comes up, scroll down. There's a map, click. And here is the map. I'm going to expand the map. I'm going to move the video of myself off the screen, which I don't think you can see, but still it's in my way. All right, this is a clickable map. And so I can zoom in different locations. And why don't I zoom in? I can also search for a place. Let me search for Carbondale, Illinois. Carbondale. Notice before I hit enter how many Carbondales there are. There are a lot of Carbondales. If you're going to a certain location and you're going to use this map or any other map where you can search for a city, make sure you're searching for the city in the correct state because Carbondale, Illinois will experience totality. I couldn't tell you if Carbondale, Pennsylvania will or not.
Oh my God, I'm going
But
crazy.
what's that?
Oh, I'm sorry. I did
Oh,
not realize that my microphone was on. You're fine. Keep
oh,
going.
no worries. We're
I was
all
I
good.
was answering emails in the background. Here I am still doing my job. Goodness gracious. I apologize,
No,
Michelle.
no, no, no. No, this is actually good because this tells me that the audio is still working and I'm not just talking to myself. And so that's fantastic. So, all right, moving on. So, Carbondale, Illinois, click. So, on the information that comes up, you've got the timing for the eclipse. The partial begins in Carbondale at 12:42:59. So, remember that is 12:42:59 plus or minus 3 or 4 seconds. The full totality occurs starting at 1:59:15. It says maximum. If you see this label of maximum eclipse and a time, that is probably the middle of totality. So just be careful on some of the sites if they list maximum for the eclipse. If it's for totality, a region that will experience totality, that'll mean the middle, not the beginning, more than likely. Just check and make sure that you're looking at when the partial or when the total begins and when the total ends. Or in this case, it says full begins, full ends, close enough. So then it ends 2:03:24, and then the partial ends at 3:18:10. Notice that Carbondale is going to start to see the moon's shadow before the Chicago area will, because it takes time for the shadow to go up and reach our location up here. Now I'm going to zoom in on Carbondale because I want to show you the other very important thing. So we're going to zoom in. I'm going to wait for this to catch up. And it's going slowly because we're using a lot of bandwidth right here. Here we go. And we're going to wait for it to catch up. Okay. Notice where the flag gets put for Carbondale. I'm going to zoom in one more time. It gets put basically in the middle of Carbondale. If that's exactly where you're going to be, great. However, I'm not going to be right there in Carbondale. I'm going to be here in Carbondale where my finger pointer is. See the times over here? I'm going to click. And the times, depending on where you're going to be, they might change a little bit. If I go over here, look, they change. So definitely it pays to try to get as accurate of a location as you can. So right here, these times are going to be basically the same as what I showed you before. But if you're going to be in a slightly different location, definitely zoom in as far as you can go. And you can pretty much get down to the block level in terms of how precise you can place your little flag here and get those eclipse timings. And Carbondale is going to get 4 minutes and 9 seconds of totality. The duration is the total amount of time for the eclipse to occur from the beginning to the end. Obscuration, how much of the area of the sun is covered. So 100% of the area of the sun. Magnitude refers to how much of the diameter of the sun is covered. Notice this number is over 1. That means the moon is going to be slightly larger than the diameter of the sun. That gives us a period of totality that lasts for a few minutes in length. So the amount of area of the sun covered is 100%. The magnitude, the amount of diameter covered is more than the diameter of the sun. Hence, we get totality lasting for 4 minutes and 9 seconds. All right. So that's a really great site. Definitely know your timing and then make sure you write it down. But remember, these predictions are plus or minus 3 or 4 seconds. All right. Okay, I'm going to go back to my PowerPoint here. All right, and then I'm going to go forward. There are a handful of other ways you can use household items to see an image of the solar eclipse, not to look through these household items, but to use them to project an image of the sun onto the ground. So notice that this person is holding a pasta strainer. Each of the pasta strainer has lots of little holes in it. Each of the holes becomes a pinhole projector to project an image down onto the ground. Again, you are not going to look through the holes. Otherwise, you would be putting a focused image of the sun onto your eyeball. You don't want to do that, but this is a way to project an image and look at the image on the ground. Okay, so anything with holes in it, pasta strainer with holes in it, the pegboard that's holding up the tools on the wall in the garage, um, an index card with a hole in it, even your hands. You could place your hands like this. So you're going to make a waffle pattern with your hands. And this is kind of hard to do when I've got the blur setting on my camera right here. And let's see if I can do this. Well, you kind of get the idea. So there we go. We've got a waffle pattern. So my fingers are like this, and then these fingers are at 90 degrees. And I'm just going to adjust the size of the holes, the spacing in between my fingers until I see crescent suns down on the ground. This is for the partial phases of the eclipse. What you're seeing here is just the effect, not with an eclipse, but with a light bulb that was in the ceiling at work. And so each of these little dots right here is an LED light bulb. So we're creating individual images of light bulbs from the ceiling. You can do the same thing with the partially eclipsed sun. Just make sure you waffle your fingers and just adjust the spacing until you see the crescent sun down onto the ground. And I'm showing you like this, just so you can see what my fingers are doing. You are going to put your fingers basically perpendicular to the rays of sunlight and then project onto the ground that way. You can use anything with a hole. I know you were all giggling at this picture right here, but this is a real picture. I have a feeling they probably cleaned out the crumbs out of the cracker holes, probably. So if you're going to do this with food, you might want to do that. And if any of you do take a picture like this, and you do get images of the partial solar eclipse, please tag the Adler Planetarium with those pictures. I would love to see them because I think that's hilarious. All right. The solar glasses or solar viewers, they all work exactly the same way. And they work by having a reflective side. I'm going to try to get this again there. The reflective side and a dark side. All right. So the reflective side is the shiny silvery side. The dark side, the black side, you can see the material is much darker. The reflective shiny side faces toward the sun. The dark side, the black side, faces toward your face. And you're going to put them over your face. Then you're going to look up at the sun. Then you're going to look down, and then you're going to take it away. Or you can put them over your face, look up at the sun, turn away, and then take them away from your face. Okay. Don't look up at the sun first and then put them on your eyes. Don't take them off your face before you look away from the bright part of the sun. So this is for the partial solar eclipse phases and only the partial. For those of us up here in Northern Illinois, you will need these at all times during the eclipse to look directly at the sun. You do not have to wear the glasses 100% of the time if you're not actually looking at the sun. If you're just walking around, you're going to want to take these off because they're actually really dark. You're not going to see an awful lot of light through them at all. You're going to see the sun and not much else. And I'm going to show you a little demonstration. I turned on the flashlight on my phone, and you notice how dark these things are. And do you see, let me see if I can do this. Do you see the light bulb right there? You see that? This shows you how dark these things really are. And then I'll turn this away a little bit. You can see I did not turn the flashlight off. It's still on. So that's blocking out a lot of the light from the sun to a safe amount. It's blocking out about 100,000 times, or it's dimming the light by about 100,000 times. It's only letting through a fraction of a percent of the light from the sun. All right. But the glasses, this shape, they're exactly the same. One you wear and one you hold. It's the only difference. Okay. Finally, there is a website from the American Astronomical Society. I'm gonna share this site as well. So give me just a second, and I'll switch the sharing on my screen because I'm going to show you this. If you might have family members who are going to be flipping out because they haven't ordered their solar glasses yet, and the news stories about the eclipse are really hitting now, and places are starting to sell out for solar glasses, you definitely want to make sure that the glasses that are being purchased are legit and not counterfeit. The big giant third party website whose name is the same as a large rainforest in South America, there are counterfeit solar glasses for sale on that site. This is not 2017 where everybody freaked out and they took all those glasses off the market. Actually, they took all the solar glasses off the market. Um, that hasn't happened in 2024. That does not mean the counterfeits aren't there. It means no one is doing anything about it. So the American Astronomical Society has created a list of legitimate, actual, real solar glasses that are not counterfeit. I want you to go to eclipse.aas.org, go to the eye safety section, go to suppliers of safe solar viewers, click on that. And on the page that comes up, if you scroll down, all of these are links to places that sell legit, actual solar glasses, stuff you should be able to trust. The American Astronomical Society has vetted the materials that are being sold by these sites. Don't just go to the giant third-party site whose name is a rainforest in South America and search for these names, because not only are the safe solar certifications counterfeited, the manufacturer's logos are counterfeited. There are people saying they're selling certain glasses and they're really not. There are people saying, oh, I'm selling NASA glasses. Just know they're either selling fake glasses or they've stuck NASA's logo onto, or they are selling glasses they got for free because NASA does not sell solar glasses. They just give them away in vast quantities. So anyway, use these links. You may have to go through several of them. There may be some that are sold out already. We are rapidly coming up against the deadline where people will be able to order them and get them in time prior to the eclipse. Maybe another few days, and that'll be pretty much it. I could probably talk about the same site next week, and that's it, because there just won't be enough time after that to get them in the mail. But there's a lot of other cool resources that are available on this site, all sorts of information about eye safety, maps of eclipse locations, all sorts of things, live streams, webcasts, you name it. This is a really, really great site. Okay, I'm going to stop sharing. And why don't we see if there are any questions? I'm a little afraid to look in the Q&A versus the chat.
Just focus on
So,
the Q&A. That's where
yes,
all your questions are. There was just a conversation with patrons in the
got
chat.
it. Hopefully,
Um,
awesome eclipse conversations going on. So
some
that's great.
Eclipse comments. So
Cool.
first question. Oh, I'm going to say that word wrong. So I invite you to also open the chat because you might, or not the chat, sorry, the Q&A. Is this the Purkinje effect with shadows? Did I say that right? I have lots of pictures
Um,
from Clarksville in 2017.
I think I only heard that name yesterday. Let me I'm gonna look that up real quick. No, so I'm looking up the Purkinje effect is the tendency for the sensitivity of the eye to shift toward the blue end of the spectrum at low light levels as part of dark adaptation. As a consequence, reds will appear darker relative to other colors as light levels decrease. And I'm reading that directly from from a website. I did not know that myself. I only heard that for the first time yesterday. That's just affecting the colors of light that you see or the amount of light that you're seeing. Essentially, our eyes are less sensitive to red in darker light levels than they are in lighter light levels, but also our eyes are just naturally more sensitive to greens and blues
Mhm.
than they are to red. So that's that. And I think that person was probably asking because of shadow bands. Shadow bands are more like if you've got light shining in a pool and you've got the ripply water and the light is shining through different densities and temperatures of water and you've got the ripples of light on the bottom of the pool. That's more like what shadow bands is. So you've seen that effect,
Mhm.
just maybe not with an eclipse. So that's a great question. Okay, the name of that site. So the site that is probably the one that they are referencing is timeanddate.com. Timeanddate.com. Um, and also eclipse.aas.org. Timeanddate.com and eclipse.aas.org. All right. So those are the two names of the sites.
Wonderful.
Will the library offer the glasses or where will they be locally? So
We
you
are
want to,
offering the glasses.
yep.
I send out an email, everyone, at the end of the program with the link to the recording of this, as well as to the next program in the series to register for. And for you guys, I threw in the link of where to register to get a pair of Eclipse glasses from the library. We still have some Eclipse kits, available. If you don't get the email for whatever reason, every now and then an email address gets typed in wrong. You can go to schaumburglibrary.org, go to our events page. On April 4th, there is an event listed so you can register to get glasses, and the library will email all those on that registration list when the glasses are ready to be picked up.
Excellent. Will the eclipse affect Wi-Fi systems, internet communications, or television signals? No, it will not. Our Wi-Fi systems, internet signal, all that stuff is due to, well, actually, I should explain one caveat real quick. All of that is due to satellites and ground towers and all that kind of stuff. And the satellites are located a lot closer to the Earth than the moon is. So you don't have to worry about that, with one exception. Those of you who I know, some of my Schaumburg groupies went to Southern Illinois and other places in 2017. I remember you telling me these stories, and I remember some of you experienced the horrendous traffic jams that occurred on the expressways, on the interstate highways after totality because everybody left all at the same time to go home. And so the eclipse itself did not affect cell phone towers. Everybody getting on the cell phone towers because they were in these massive highway traffic jams essentially crashed the cell phone towers. So it wasn't due to the eclipse, it was due to all the people on the road trying to get on Google Maps, trying to find if there was an alternate way home. And so nobody could get on the internet along the highways. So it's indirectly due to the eclipse, but not actually from the eclipse itself. All right. What was the shortest solar eclipse? So the shortest solar eclipse would only be a few seconds long. I couldn't tell you the absolute shortest, but just know that it would be a few seconds long. That's where the moon is just basically exactly the same size as the sun in the sky. What you got to imagine is, just think to yourself, how amazing is that? The moon is 400 times smaller than the sun. This little thing can block out this big thing because the big thing is 400 times farther away. So the moon is apparently the same size as the sun in the sky, or in this case, just slightly bigger. So the shortest solar eclipse would be when the moon is just about exactly the same size, appears just about exactly the same size as the sun in the sky. I would have to look it up to know, to find out about the shortest. If you're wondering about the longest can be 7 minutes and 29 seconds of totality. All right. Okay. Do you need to worry about light pollution when finding a spot to view the totality? Would a spot further out of the city have better viewing or any place in the path? Basically, any place in the path. You have to worry more about weather and clouds than you do light pollution. The great thing about the bright part of the sun, it's bright. The great thing about the corona is it's about as bright as the full moon. So if you can see the full moon in a city sky, you can see the corona in a city sky. The great part about the planets is they are also, during totality, they're also going to be readily visible, except maybe the dimmer ones might be a little harder to see. So that's where that eye patch comes into play. But it's less about light pollution and more about how long you have for totality and the weather and clouds and that sort of thing. Um, with one exception, if you go to a city location where they haven't done a great job of anticipating the light levels whereupon their street lights come on, you might experience the phenomenon of street lights coming on in the middle of totality. That has happened before. Cities have done that because they're on um, light detection devices and they don't disable those during totality or for totality. So if they haven't done a good job of planning those, so you may get some artificial light pollution related to the eclipse. Okay. Will I-57 be a massive traffic jam on Sunday? I assume they mean Sunday, April 7th. So prior to the eclipse, we don't anticipate giant traffic jams, mainly because most people are going to be spread out all along the path of totality, even those going to cities, especially those going to cities, because a lot of the hotels are requiring 3 night minimums. And so you're going to be getting people arriving on Friday night, Saturday night, Sunday night, and those folks may have to stay for longer periods of time. You're going to get the traffic jam more than likely on Monday, April 8th, after totality, when people go, I got to go home. I have work the next day or I have school the next day. So that's where the traffic jams will come about. This is what I definitely told y'all in 2017, and I'm repeating the same story. Take a paper map with you. Wherever you're going to go, take a paper map or download maps. So, for example, Google Maps does an offline map version. You can download an offline map of Google Maps into your phone, and it doesn't take a lot of memory to do it. Just make sure you download a map that covers the whole location, the whole trip in between where you're going and where you're coming from and where you're going to, everywhere in between, and some regions around there, so that you have a way to look up alternate ways to drive home off the highways. And better yet, you may just want to find an alternate route home that just doesn't use the highways. It may take you a little longer than it would if there was no traffic on the highway, but it'll probably take less time than it would if you were um, stuck in those traffic jams. So give that a think. Okay. Any effect to ham operation? I don't think so. I would need a ham operator to definitely answer that question for sure. I don't think there are effects for ham operation. But if I got that wrong, I definitely would appreciate a ham operator chiming in and mentioning if there are any solar eclipse effects. Why would some eclipses be as long as 7 minutes if the moon is even a little closer to the Earth at its close point? So the moon's orbit can take it to as close as about 220,000 miles away from the Earth. And so even closer than 223,000 miles as to what we're getting on April 8th. If you're at about 220,000 miles, that's when you're going to get that 7-ish minute long total solar eclipse. There we go.
Awesome.
Oh yeah. Carol says, don't leave after totality, stay another hour and watch the other half of the sun crescent. Yeah, enjoy the rest of the eclipse as well. If you're going to get stuck in traffic, you might as well wait until you see the rest of the eclipse and then go home. So, great point, Carol. Thank you for saying that, because that's what I'm going to do. I'm just going to sit back and go, man, that was cool, I hope. I hope that's what I'm doing after April 8th. But if anybody's going to Carbondale, I'll be in the football stadium there at Southern Illinois University. So we'll be hosting the stadium show there. So that's going to be a lot of fun.
Michelle, I have a question for you. I asked this to all of my presenters, and this is a weird one. I have to warp it. I try to ask, what is something about topic we've discussed that's affected the way you live your life. And I don't know how a solar eclipse specifically, but as someone who's dedicated a lot of their life to learning about our solar system, what is something that you've taken away that affects the way you live your everyday life? How is studying our solar system and eclipses too, I guess, changed your view of the world?
So this is something that has changed my view only relatively recently because I only came upon this thought within the last maybe 2 weeks. And this is something I've been fascinated with astronomy ever since I was a little kid. But I realized that solar eclipses, more than just about any other astronomical phenomenon that I can think of, is incredibly sensory. You see the eclipse in the sky. You feel the temperature drop prior to totality. You feel the temperature rise after totality. You see the light levels drop just prior to totality. You hear birds roosting in the trees. You see animals doing interesting things during totality. Um, this is one of the few astronomical phenomena that engages your sense of sight, your sense of hearing, your sense of touch, how the air feels. It's not often that you get to say that about just about anything else, and that's something that I try to impress. That I ever since I realized that I've been saying it, and to impress on people that this is a combination of you, the Earth, the moon, and the sun. And these are objects that are so familiar, and yet for a short period of time, they look so different. And it just goes to show you that even though I've been doing this for close to 50 years, because I started getting interested in astronomy when I was 4, um, that you can always take something away from it that affects your life. And if you are lucky enough to see totality, it can be life changing, at least for a brief period of time. Maybe not forever, but at least you instantly have a connection with humans of the past who were terrified of this phenomenon because they didn't know it was going to happen. They didn't realize it until the sky suddenly goes dark and all of a sudden the sun disappears. And you don't know if the sun is going to reappear. And so you instantly understand what they went through because it looks crazy weird and it can be temporarily terrifying or awe-inspiring at the same time. So um, Carol says, remember the champagne toast after totality or whatever beverage, sparkling water or otherwise, you would like to hoist for totality. Definitely consider doing that too. And I don't know if Carol was um, in the audience when I was talking about this in 2017, that the first totality that I saw, we were on a cruise ship, and everybody's job who came with the Adler Planetarium group on the cruise ship, this is in 1999, everybody's job was bring a bottle of champagne because that's what we did right after totality, pop the champagne corks, and because it was spectacular and is just like nothing I'd ever seen before. Um, so I hope that was a suitable answer to your question.
Wonderful. Well, Michelle, I want to make sure that we are being, Carol was at your presentation in 2017. I want to make
Oh,
sure we're
yes.
being respectful of the time that you promised us this evening, and of course, the time that we were expecting of our patrons to be with us this evening. So I think this is a great time to wrap it up and say that you covered everything in this presentation to its totality. So I tried my best there to pun it out for you. Um, So I also do think that we might have beat Wheaton. I'll have to pull my Zoom report after we get off this, but I'm gonna email you and let you know. I think we beat Wheaton. I think we did it, guys. I want to thank everybody so much for being here with us this evening. And Michelle, of course, thank you for once again spending your time with the Schomburg Library. Don't forget, I will send out an email with the link to tonight's presentation to get your glasses. And for next month's session of Night with the Museum, next month is pulled up on my phone so I wouldn't forget. The 16th of April, yep, from 7 to 8 p.m., we're going to be visited virtually by the Mariners Museum and Park for a wonderful presentation about the Titanic. So make sure you guys, I've worked with these people before. They do really good presentations about the Titanic. So I can't recommend it enough. So I hope you guys, maybe Michelle, you'll register and jump on with us too. I hope to see you guys next month and around the library. So have a wonderful evening, everyone.
Thank you. Clear skies, everyone.